Hello, this is Dr. Ruchira Chakraborty and I am going to solve some problems related to JEE Mathematics. The problem is the time is too short and you have to solve enormous types of problems within this short period of time. So let's start and see how much it takes time to solve 5 problems.
Problem 1. F is a mapping from this interval 0 infinity to 0 infinity interval, and fx has been defined as x divided by 1 plus x, and you have to find whether f is bijective or not. To test 1 I have taken two distinct elements from the domain interval 0 infinity, that is x1 and x2, and if x1 equals to fx2 implies x1 divided by 1 plus x1 and x2 divided equals to x2 divided by 1 plus x2, that is this step. And by the calculation of this we get x1 equals to x2 provided x1 x2 is non-zero. If x2 equals to 0, then implies either x1 equals to 0 or x2 equals to 0, and x1 equals to 0 implies fx1 equals to 0 and x2 equals to 0 implies fx2 equals to 0. So x1 x2 are non-zero two distinct elements, and fx1 equals to fx2 ultimately implies this x1 equals to x2. So f is 1 to 1. And to test on to, I have taken any arbitrary element y, that is from the codomain set 0 infinity, and y equals to x divided by 1 plus x implies x equals to this, and this is valid for y to be not equal to 1, because y, if y equals to 1, then x will be undefined, but 1 is included in this codomain set 0 infinity, so that implies 1 has not any preimage in the domain set 0 infinity. So that implies the mapping is not onto. So B is the correct option, that is the mapping is 1 to 1 but not onto. Problem number 2, that is fx has been defined as fx equals to x when x is rational, and fx equals to 1 minus x when x is irrational, and you have to find f compose fx. Now, when we will consider two cases, when x is rational and when x is irrational. And when x is rational, f compose fx equals to f of fx, that is f of x, because when x is rational, fx has been defined as x. So I put the value of fx as x, and fx equals to x when x is rational. So ultimately f compose fx equals to x when x is rational, and when x is irrational, f compose fx equals to f of fx, and I put the value of fx equals to 1 minus x because x is irrational, and again f of 1 minus x will be 1 minus uh, I put the value of 1 minus x in place of x because x is irrational, and by the cancellation of 1 I get x. So f compose fx equals to x when x is irrational. So either x is rational or irrational, f compose fx is always x. B is the correct option. Problem 3, f has been defined as fx plus 2 equals to fx plus 2 equals to a2 of fx 2fx minus f of x plus 1, and f0 and f1 has been given. You have to find the value of f5. To find the value of f5 you have to put the value x as 3, so f3 plus 2 equals to 2f3 minus f4, and Again, you have to find the value of f4. So you have to put x as 2 and f2 plus 2 equals to 2f2 minus f3. Again, to find f3, you have to put the value of x as 1 and f of f1 plus 2 equals to 2f1 minus f2, and finally get the value of f2 by putting the value of f0 and f1, and f0 f1 has been given in the question. So we get the value f2 as 1, and by putting the value f2 in the previous equation we get the value f3 as 5. Again, by repeating the same process, by putting the value f3 in the previous equation, we get the value f4, and finally you get the value f5 as 13. So B is the correct option. Problem 4. A is the interval this, and F is a mapping from A to A. A is the interval closed interval minus 1 1, and F is a mapping from A to A, and I have to find which of the following function A, B, C, D are invertible, means inverse exist. To get the function to be invertible, the function should be 1 1 and on 2. That is, the mapping should be bijective. Now 1 1 on 2, which of these four function I have to find the on 1 1 or on 2, 1 1 and on 2. Now clearly C and D are not 1 to 1, because in both cases you see minus 1 has been mapped into 1 and also 1 has been mapped into 1 in case of C and in case of D also. So the two distinct element minus 1 and 1 are mapped into the same element, that is 1. So C and D are not clearly 1 to 1. And option A, for the option A, we see that the function is 1 to 1, but the function is not onto, because if we take any arbitrary element y in the codomain set minus 1 1 into, that is the interval minus 1 1, and y equals to x divided by 2 implies x equals to 2y, and if we take y to be 1 we get the value x to be 2, but 2 is not included in the interval minus 1 1. So it implies the element 1 that is in the codomain set, codomain interval minus 1 1 has not any pre-image in the domain interval minus 1 1. That is, the mapping is not onto. So 1 is not also invertible. The option A is not also invertible. So clearly the option B is the correct option, that is the function gx is equals to sine of pi x by 2 divided by 2 is inverted. Problem 5. If fx plus 2 of 2f of 1 minus x has been equals to x square plus 2. Now I have to find the value of fx. Now this equation has been given in the question. I have numbered this equation as 1, and I have put the value of x as 1 minus x, and I get the another equation, that is the equation 2, and I have multiplied equation 2 by 2 and get another equation, that is the equation 3. So by subtracting the equation 1 from the equation 3, we get the value fx as x minus 2 whole square divided by 3. So A is the correct option.
So that's all about the 5 problems we managed to solve, and it almost takes 9 minutes to solve that problem. So I think it will take lesser time if you solve it by yourself. My next target is to solve some problems related to plane and straight line. If you like my video, subscribe my channel and stay connected with the RC's math class.